G'day YouTube, welcome to part 3 of my 2G base station tutorial series. In part 1, we covered the topic of configuring the hardware and software of YateBTS, and in part 2, we covered some basic usage of our 2G base station, such as voice calls, SMS messaging, and GPRS data. So what exactly are we going to be covering in part 3 today? A common misconception about a rogue 2G base station is you can just set one up, deploy it, and start doing naughty stuff. This isn't exactly the case. It's a little bit more complicated than that. So in this video, I'm going to be showing you guys how to do some naughty things with a 2G base station. And we're going to do it in an experimental laboratory environment, of course, because you have to be aware of these kind of attacks first before you can start defending against them. So yeah, that's just a message directly to the YouTube censors. If you don't know if people are doing naughty stuff, you can't defend against naughty stuff. But before we can get into this video, I can't continue without reading my usual disclaimer. So while playing around with experimental 2G base stations is enjoyable and educational when deployed in a laboratory environment, deploying them in a public setting for malicious purposes is highly illegal, and it will cause destructive interference to licensed services operating on those frequencies. If you get caught by law enforcement using my tutorials to intercept and steal private user information and data, I promise you the penalties will be extremely harsh and you'll be going to prison for a very, very long time. If you value your freedom, you should never, ever, ever follow this tutorial or any of these tutorials here. So I've got my obligatory video recording beer here, so I'm going to have a sip and then we are going to get stuck into it. There's also a lot of things that need to go right for me to record this video in a single take. But yeah, if things start going pear-shaped and I can't troubleshoot them on the fly, I'm going to have to start like maybe pausing the video and doing some post-production editing. So I apologize for that, but we're going to try and do it all in one sitting, hopefully. So before we can get started with using our 2G base station, we've got to launch it. So you guys might have noticed maybe in part 2 that when you run YateBTS, it just floods the terminal with heaps of useless information. And people get hung up on the fact that there's heaps of error messages showing in the terminal. Again, in Linux, sometimes errors aren't always a bad thing. It's just telling the user that something's not 100% right, but if it's still working, why complain about it? So if we run this command here, you can see I'm using grep here. So I'm just going to run this to launch the 2G base station. Receiver clipping. So you might see messages saying receiver clipping in the output of YateBTS. So what's happening here is maybe a phone is transmitting at very high power, trying to talk to the base station, and it's actually overloading the front end of the BladeRF SDR. If you have an overloaded front end, it can lead to distortion of the received signal and cause connection dropouts. So this command I'm running here will show us if the BladeRF receiver is being overloaded. Because nothing is currently connecting to my base station, we can't see any messages, but later on in the tutorial, we should be able to see them, and I'll show you what it looks like. Okay, the next thing we're going to do is I'm going to show you guys how to use YateBTS as an IMSI catcher. I'm not going to explain what an IMSI is or what an IMSI catcher is, because most people that are into GSM and have been watching my channel for a while should know what that is. But if you don't know what an IMSI or an IMSI catcher is, pause the video and go and do a Google search about it. So we can see what IMSIs are attaching to our base station through the YateBTS telnet interface. So what I'm going to do is I'm going to run this command here. I'm going to type sniffer on. I'm going to type sniffer filter user.register. We're going to hit enter on that. And then I'm going to type output on. So what I've just configured the YateBTS telnet server to do is to only show us information regarding when a phone is attaching to the base station. And the IMSI is the unique identifier of a SIM card and a mobile device on the network. So it will show us the IMSI number as it tries to attach. So I've got my Galaxy S9 here with screen copy here. So what we're going to do is I'm going to move this over here. And I'm going to turn this Galaxy S9 off of flight mode. And then hopefully it should attach to the base station. And then we can see here in the YateBTS telnet, we have an IMSI right here. So this is the IMSI of my Galaxy S9, which is here. And it's successfully attached to the base station, as we can see. So yeah, that's pretty cool. And what I was telling you guys before about the receiver clipping, right? So I've got my YateBTS, so I've got my BladeRF in my garden shed, which is probably like, I don't know, maybe 10, 15 meters away from my current position here. So quite close. And we are seeing a very strong signal being transmitted from the phone out to my garden shed. Nothing to worry about, but it's just handy to know when our BladeRF is getting overloaded. Okay, so what I'm going to do now is I'm going to show you guys how to tap information from the base station. So people that are pretty handy with using GPRS will probably know that if you use GPRS Live Monitor, we can monitor the control channel and you start seeing all the system information messages and stuff like that, right? That's called GSM layer 3 messages. So without using an SDR, we can actually tap the GSM layer 3 messages flowing over the base station without an SDR or GPRS. So that's really cool. So I'm going to open up a third terminal window here. And I'm going to, well, not run this command yet. But what I'm going to do is I'm going to go into the YateBTS. This should have already been opened. I apologize for that. We're going to go to the YateBTS configuration GUI in our browser. You can access that via that address there. And then what I'm going to do is I'm going to go to the BTS configuration tab. I'm going to click on tapping. And I'm going to tick these two boxes here. So we're going to tap GSM layer 3 messages. And we're going to tap GPRS, I think it's layer 3 messages, I'm not sure. And then we're going to hit submit. And then if I minimize my browser now, and then I'm going to run this command, which everybody should be very familiar with this command. It's the exact same one we use for GPRS. I'm going to hit enter on that. Apologies. So we need to quit. I forgot about this. Sorry to tell you guys. We need to quit YateBTS. I always run this command after quitting YateBTS because it will actually reset it'll actually reset our BladeRF for us. So yeah, so I always run that first, and then it just gets our BladeRF back to square one again. And then I can run the YateBTS launch command again. So I apologize for that. I didn't actually write that in my notes here. So and there we have it. We've got the GSM layer 3 messages beginning to flow in our Wireshark window here. So yeah, that's very, very cool. So the next thing I'm going to show you guys now is GPRS messages. Sorry. So it's not layer 3 messages. It's actually TCP IP. So we're up into the layer 4 and 5s of the OSI model here for anybody that is proficient in networking. So we can actually see when our mobile phone is, doing HTTP requests and DNS lookups and stuff like that. So it's actual TCP and IP traffic, which will be flowing to and from the phone from the base station. So it's actually different from layer 3, which is just like system, like the actual physical, or it's almost a physical layer of the GSM communication stack. So this is the TCP IP. So what I'm going to do is I'm going to hit enter on that, and we probably shouldn't see too much at the moment because I haven't activated the GPRS data connection on my phone. So what I'm going to do is I'm going to bring the Samsung back into view here, and I'm going to activate mobile data. And hopefully we should start to see some messages. That's if it attaches to GPRS. It might take a little while. This is the problem here. So if you guys are struggling with APRS, APRS, it's like I'm a ham radio operator now. GPRS data connection, you need to just write anything. So you can just write data. So there needs to be at least one APN programmed into your phone. So it can be called anything. It's just arbitrary. It doesn't mean anything. So I'm just going to write data and then OK. And then hopefully, if I maybe put my phone in flight mode, hopefully we get an attachment to GPRS. Again, we're dealing with base stations operating on SDRs. Like they're never going to be a solid replacement for a proper 2G base station hardware. So sometimes stuff doesn't really work the first time. You just got to keep trying. Just persist with it. You can see the phone's definitely attached to YateBTS. Oh, there we go. Okay, cool. So we've got some TCP IP traffic happening here now. So I'll move this out of the way so you guys can have a look at that. There's a lot going on in this video today. That's why I've sort of got to have heaps of terminal windows open, unfortunately. So yeah, I think everybody's had a good enough look at that for now. So yeah, that's a very, very nice feature. When you're dealing with the YateBTS, it's always good to turn off mobile data and put your phone in flight mode, right? Because if you start doing stuff too fast and everything, it just YateBTS just can't handle it. So yeah, make sure you guys are doing that. Okay. All right. So I'm going to talk about changing the welcome message. So when a phone connects to YateBTS, it will always send a message like this, just saying, hey, your phone number is such and such, and you can call David, which is the IVR system, right? This could alert somebody that malicious activity is afoot, okay? From an attack, from a bad guy's standpoint, you probably don't want your base station sending these messages to people, because then people will just know, uh-oh, something's wrong here. Someone's trying to steal my data, right? So wouldn't it be cool if we could change the welcome SMS message? So this message here is something that people in Australia know a lot about. So Australia's very big, right? And it's very sparsely populated. So when we travel long distances in a car, for example, you get these messages very, very common on your phone, right? Because they've got this particular carrier has things called 4G small cells, and they just mount on a light pole or something like that. They're very, very small cells, and they just cover a sort of the intermediate area, such as like a fuel station in the middle of nowhere or something like that. So these things these messages here are very common. So what I'm going to do is I'm going to change my welcome message to emulate a legitimate looking message from a carrier in Australia called Telstra. So I'm going to minimize my browser now. And I can probably close... I'll just minimize this stuff for now. We might need it later. And what I'm going to do is I'm going to run this command to open a file called nipc.js. And that is the JS, I guess it's JavaScript. It's the JavaScript thing that's in charge of the network in a PC, which is like the software side of a GSM base station. So I'm going to run that command. Just open this up a bit. And I'm going to go to search, jump to, and then I'm going to go to line 385. Sorry. 385. And the text we are targeting is right here. So between the two double quotes. So what I'm going to do is I'm going to copy the message from a legitimate looking message from Australia's biggest cellular provider. We don't have 2G here anymore in Australia, okay? I'm not doing anything bad here, okay? This is just for experimental, laboratory, educational purposes, okay, YouTube sensors? So yeah, you can see here that I've actually replaced the standard message that YateBTS ships with, and I've actually changed it to the one from the carrier in my country. So I'm going to hit save, and then I'm going to, I might have to give admin permissions here. Yep, so that should have saved now. I can actually double check that actually happened by just by opening Featherpad again, and we'll just jump again. We'll jump down to line 380, wherever that was. What was it? 385. Yep, so that was successful there. I just had to double check that because sometimes everybody knows what Linux is like. Just kidding. I know Linux is awesome. Now, what should happen now, if we're lucky, is I need to just run a script quickly to erase my TIMSI data. Don't worry, I'll explain what the TIMSI and all that is later on. So I just need to run this command quickly. Okay, cool. We're back to square one now. Okay, now hopefully I'll delete this welcome message here on the Galaxy S9, and then I'll turn flight mode off, and then it should reattach to the base station, and then we should see the new welcome message, hopefully. And right on schedule, we have our new welcome message in YateBTS, so that's pretty cool. Obviously, you've still got this number here, like this 1, 2, 3, 4, 5. So, but most people should just go, you know, it's just another Telstra message, and then just forget about it. So, in an experimental and theoretical setting only, of course, because you guys are good boys, you wouldn't do this to a real person's mobile phone. I know it. Okay, so what we're going to do now is so YateBTS has like this hidden menu where you can actually send SMSs to known IMSI numbers attached to the base station. So you could just send like a text message, right? So it's actually a hidden message. There's no links to it in the web GUI. So I'm going to open my browser once again, and I'm just going to refresh the page. And so this is the hidden menu, right? So you guys can just access, hopefully you guys can see that. I think, yeah, I can see it. So yeah, if you guys just go there. to that address, it should just come up in the browser. So I know the IMSI number of my Galaxy S9 is here. Oh, sorry, I mean the Galaxy S9 here. I know that this is the IMSI of it. So, and I'm just going to write something simple like, this is a text message. And then we're just going to confirm that we've got text selected from the drop-down menu here. And then I'm going to go send SMS, and then I'll bring my S9 back into the frame, and then let's see if it's going to work. So sometimes it takes a little while. If it doesn't work, you'll get like an error message come up in the top left-hand corner here somewhere. And it will also say if it's successful too. So we'll just wait a bit. There we go. So yeah, this is a text message. So yeah, that's pretty cool feature. You can't actually reply to this. I believe it's only a one-way messaging system. So you can't, yeah, I don't think it's bi-directional. So yeah, basically you can send text messages to people without having your own phone connected to it, to YateBTS. So yeah, that's very cool. Okay. All right. So another misconception about 2G base stations is that they will allow you to intercept a phone call. Now, this is wrong, okay? If a mobile phone is connected to YateBTS and it can't contact the outside world, what data will there be to decode? There'll be none. There'll be no data because the phone can't talk to a real base station, right? So how do you connect a phone to a real base station? And the answer to that is, I'm not going to show you because good friend of the channel, an absolute Linux magician, wizard, has already done that for you guys. And I collaborated with him in part 2. So Aaron actually called me from America, the US, to Australia where I am, and then we were having a conversation. So he called me through my telephone carrier. So I was just using my normal phone to talk to him through YateBTS, which is just absolutely wild. So yeah, Aaron's already done this, so I'm not going to show you guys how to do it. However, I will show you guys how to actually record the voice calls that you or someone else might be making through your GSM base station. So yeah, the way he's done this is he's done it with a third-party SIP and IAX provider. So yeah, that's really cool. I haven't tried it yet because I guess I'll have to find a SIP AIX provider in Australia, which I haven't really looked into yet. But I definitely want to do it because yeah, these two videos, man, are absolutely insanely awesome. Like, Aaron doesn't get enough thanks for what he does for the SDR scene, man. Like, really, go and give him a follow and a like and a share and all that, man. He's so good. All right. So yeah, a lot of stuff's got to go right for this next demonstration now. So I've got a second phone here. I'm going to turn this off flight mode, and then hopefully it attaches to the base station. And then what I'm going to do is I'm going to conduct a call between this phone and the S9, and then I'm going to record the traffic with GSM capture, and then I'm going to extract the voice data between these two phones with GSM decode. Okay, so fingers crossed this is going to work. Okay, after a lot of technical difficulties, we may almost be at the stage where we can start running the GSM capture command and making a voice call between my two phones. So I'm going to run the GSM capture command, and then once that hopefully works, okay, all right, we've got data being captured. So I'm going to proceed to dial the Galaxy S9. And then I'm going to lean over and then just generate some voice traffic. G'day, YouTube. Welcome to the VK8 FOES YouTube channel, testing YateBTS voice call with a Galaxy S9 and Galaxy S8. Thanks very much for watching. Bye. So hopefully that works. So I'm going to go ahead and quit the GRGSM capture command. So yeah, I had a lot of issues with just trying to get this to like blog R4 RTO SDR to work in virtualization. Why do you guys do it to yourselves? I've got a tutorial coming where I'm going to show you guys how to make a bootable Dragon OS USB drive, because yeah, it's no good, guys, no good. But anyway, I think we've successfully got some. We've got some. Hopefully we've got a voice call in here. So what I'm going to do is I'm going to run the following command, and this should extract the voice traffic, which is on a TCHF channel, which is traffic channel full rate, and it should either be time slot 4 or time slot 5. So because I've got two phones talking to each other, one will be on time slot 4, the other will be on time slot 5. So first I'll extract the audio from time slot 4. Okay, it's finally worked. All right, so we can see here we've got a .gsm file with a size of 32.4 kilobytes, which means that there is voice traffic in there. So I'm going to use VLC here to just drag that into here.
G'day YouTube. Welcome to the VK8 FOES YouTube channel, testing YateBTS voice call with a Galaxy S9 and Galaxy S8. Thanks very much for watching. Bye.
Cool, so that was one side of the conversation, and we can extract the other side of the conversation because I'm using two phones on the same network, remember? I can extract the other side of the conversation by decoding time slot 5. So yeah, hopefully this works. I'll press enter on that. Hallelujah, it actually worked. Okay, we've got 32.2 kilobytes of voice traffic here. So I'll drag that into VLC.
Just generate some voice traffic. G'day YouTube. Welcome to the VK8 FOES YouTube channel, testing YateBTS voice call with a Galaxy S9 and Galaxy S8. Thanks very much for watching. Bye.
Okay, so yeah, that's how you do that. That's very awesome. It actually worked. Okay guys, we finally reached the last section of part 3 of the YateBTS tutorial series. So what I'm going to do now is I'm going to show you guys a real world practical man-in-the-middle attack. Obviously in a experimental, theoretical laboratory environment, of course. So you can see two bash scripts that I've written displayed on my screen here. So this bash script on the right here, that's just going to do something very simple, like automatically log us into the telnet server, so we're not typing heaps of stuff in there. So it's just going to get us straight to where we need to be without having to type so much text. And the bash script on the left, that is going to automatically change a few details in the YateBTS configuration for us. So I'll just go to YateBTS, and at the moment the SIM cards that are inserted into my phone, as we alluded to in part 1, have an MCC and an MNC of 999 and 70. So that means that devices with SIM cards programmed with IMSI numbers of 999 and 70 are only going to connect to this. But what if I told you that there is cellular devices still out there, even in the year of 2024, that still try to attach to a base station regardless of what the MCC and MNC is, okay? And that's what you can see in this image here. So this image here is the output of the YateBTS telnet, and we can see that a device with an MCC of 262 and an MNC of 01 has attempted to attach to a rogue 2G base station powered by YateBTS. So I'm going to call this a rogue cellular device. Now, these things exist. It happens all the time, actually. I've actually got one here. So this is a 2G, 3G internet dongle that was gifted to me by my father-in-law. It's really, really fun to play around with this thing. It's locked to a carrier, though. So it can only connect to whatever carrier it used to be, and that was the Optus network here in Australia. But yeah, it's got this cool little GUI where you can send text messages and everything. So it's pretty fun bringing this old 2G hardware back to life again. So yeah, so are you guys following with me? So wouldn't it be nice that if we could just monitor for these location area not allowed messages, and then we could quickly, on the fly, change YateBTS to connect to whatever the MCC and the MNC of the rogue cellular device is? Wouldn't that be cool? Well, guess what? Your Rob boys got you sorted on that one. So yeah, using these two bash scripts here, we can quickly do this very fast. So I'm going to minimize that. So I had to reset up everything here. So I don't have YateBTS running yet. But what I'm going to do is I'm going to initialize it. And then while we're waiting, I'm going to initialize my 2G dongle here. Well, it's actually 3G, but it downgrades to 2G just fine. We're actually turning 3G off in Australia now. The one network's already done, and the other two major telcos will be doing it in, I believe, 31st of August for my carrier, and then another carrier, the smaller carrier in Australia will be doing it in, I think, October or November or something. So yeah, our 3G sunset is not going to be around for much longer. So what I'm doing now with my 3G modem here, I hope you guys can see that properly. So I've done a manual search for a carrier, and that carrier is my YateBTS base station, obviously, because we don't have GSM here in Australia. So what I'm going to do is I'm going to run this command here, which is going to log us into the, whoops, sorry, that's not the right one. I'm going to run this command here. So this is going to log us into the Telnet server, and then it's going to only show us when rogue cellular devices try to attach to our base station. So I'm going to hit enter on that. And then I'm going to open up my Windows 7 virtual machine. So the reason I'm using Windows 7 for this, guys, is because I don't want it to stuff up my network settings on my machine, my Windows 10 machine I'm using here. So what I'm going to do is I'm going to click select on that and try to attach, and then we're going to see what's going to happen here. And as you can see, we get an unsuccessful message from my 2G modem, and then we also get a location area not allowed. So we can see from here that the MCC and the MNC values are 505 and 02 respectively, and they belong to the Optus network here in Australia. So wouldn't it be nice if we could quickly change YateBTS to reflect this, and then have my 2G modem attach, and then we can start man-in-the-middling it? Wouldn't that be nice? I'm going to show you guys how to do that right now. I'm going to quit YateBTS here, and then while it's doing that, I'm just going to reset it back to, I'm just going to run that command just in case. I like resetting everything back to square one. So obviously you wouldn't do all this in the real world, but I'm just doing it because I need it to work the first time because I'm recording a video. So I'm going to hit enter on that command, and then I'm going to change it. So it's my script's prompting me for the MCC. So I know that it's looking at this terminal window. I can see it's 505, and then the MNC is 02, And this value is arbitrary, but I know it's Optus, so I'm just going to write Optus like that. Or maybe I'll just go lowercase and then hit enter on that. So my script will now proceed to restart. It'll reset the YateBTS with SOAPy SDR, and then it will restart. It'll restart YateBTS. So I remove the grep from this now, and I just run that command now. So now the telnet server is just going to tell us when a device connects now, and not when a device is not authorized to connect. So I'll go back to my Windows 7. I'm going to conduct another manual GSM search. I'm going to click OK. And now we have Optus is now showing. Kind of looks like this little 2G modem wants to connect, doesn't it? Let's click select. And then if everything goes well, we should see it attached to the base station. It's taking a long time. I'll just reset it quickly. And while that's resetting, I'll just launch that command. And we'll see if we can get see if we can man in the middle some data from it. I've had to stop and start and try and troubleshoot stuff that I've actually run out of beer. That never happens. Normally the beer will last me for the whole video recording. I'm going to try and attach to the base station now. And there we go. So I reset, fixed it. So there we have it. That's actually my obsolete 2G modem actually just attached to YateBTS. So could still be people using these things in the world, guys. Okay, and it looks like. So yeah, this is really cool, man. Like this little obsolete dongle here, you can send messages and everything here. As you can see, I've sent a few test messages to myself, and so we've got the welcome message coming through. Yeah, it's really, really cool. It's very cool to bring this like old 2G hardware back to life. So if I click connect, hopefully we get an attachment. Okay, so we're actually connected to the internet via YateBTS, so we can start man in the middling this traffic now. It might be a long shot here. This isn't in my script, but we can actually launch Google Chrome, and I can just show you some traffic, some real 2G GPRS traffic coming through. So this is called a man in the middle attack, guys. I can directly look at or modify or TCP hijack or DNS hijack, anything like that. So and I have it on very good authority that there's still devices out in the world that are susceptible to this attack. So I'm just going to go to a I'm going to attempt to go to a just a text-only website. NPR, is that like some kind of American news outlet or something like that? I don't know. In the US. So yeah, it doesn't look like that's going to go. Obviously, GPRS is very, very slow. The data rate is like incredibly slow. You can see here from the statistics of my 2G modem here that, yeah, it's not exactly the fastest thing on the planet. We got 6 kilobits a second coming down. So, yeah, not sure if this is going to work, but Yeah, I don't know. I think this video has gone on long enough, guys. You guys are probably sick of this by now. So yeah, anyway, that's just my theoretical attack vector for this stuff. For yeah, practical man in the middle attack. So yeah, I hope you guys enjoyed that video. Apologies for everything not going 100% according to plan, and that's blown out the length of the video. But if you guys are interested in this, I'm sure you can modify your TikTok brains to watch something for more than 30 seconds, hopefully. So, no, I'm just kidding. I know you guys are smart people and don't watch that garbage. Okay, so yeah, thank you very, very much for watching. I know I was promising you guys that I was going to promise you guys that I was going to do some troubleshooting, but this video is long enough, so I may or may not do a part 4. Oh, here we go. We've actually loaded the NPR website, so on hardware from the early or the late 2009s, probably early 2010s. So, and look at that, it actually loaded. Yeah, okay. Anyway, that's all for this video, guys. Thanks for watching. I'll catch you in the next one. Bye.